This is the video on how to, for Salkind Chapter 1 and Central Tendency in R. So if you come to the course, you go to Modules, you'll see the video posted here once I'm done with it. This file right here is a data set that we're going to use in class today, so you'll want to download that and save that to your computer. This is the PowerPoint for the lecture, and this is the R code. So I've already downloaded the PowerPoint. I'll just download them again, the PowerPoint slides. And then, there we go. I can go next, and I can download this R code. So what you should all get used to doing, it'll make your life in R easier, is when you download these files, you should go always open files of this type. Well, hold on. Well, if I go show in folder, then what I do is I right click on this, and then I say open with, and then I can just say RStudio, and then it'll set it up so that it always opens these files in RStudio in the code section. I sort of showed you this the first day of class, but so right here is where you have code. Right here is R that runs the code, and then this is my environment. I have my history there, I have my environment there. It's all empty right now, and like packages and help and stuff like that I do over here. If I want to run some code from here, I can just put my cursor anywhere in here, and when I push Control and then Enter, it runs that code. Okay. So we'll open up this slideshow. So lots of people hate R, but I don't think you should be one of them, because I'm going to teach you how to use R in ways. So I hope that by the end of this semester, or pretty soon, you're one of the people that loves R. And if you use RStudio the way that I teach in this class, I think it makes using R just about as easy as using SPSS or Excel or anything else. You might think that maybe Excel's easier, but that's just because you're used to it and you know how to do it. I think R is easier than Excel for many, many things. So how do you import a data set into R? Right, this attribution 2 data set that we can download from iLearn. We'll go back here and then download that data set. So if I click on that, it downloads it. So if I just do open, it's going to open it in Excel, and then it's going to give me the data set in a format that most people are used to. We don't want it to open in Excel. We want it to be in R. So the question is, how do I get this data set that I've saved into R? There's a couple of ways you can do it. I'll first show you the easy way that you do it. So if you go over here, import data set, let me go to my R window. If you go import data set, this is RStudio's updated itself from when I made those slides. So you can choose base R or read R. I'll just do base, it doesn't matter. And then this window is going to pop up and you choose the data set that I just downloaded. So then I'll just search for attribution 2. Attribution, okay, so I've got to go to this other way that I've got my other place to find my downloads. There it is. So then I select attribution 2. Then here it shows me what the data set's going to look like once it's read in. I'm going to give the name of the data set a name called D1. And then when I go import, I'll know that I did it right because I have this data set called D1 that has 1,052 rows of 35 variables. So that's one way I can read in a data set into R. That's, I know, what seems like the easiest, simplest way, but this way is actually the better way to do it. D1 equals, this little symbol here means equals when you're writing code, but I can just change that little symbol to an equal sign. So this says read in an object that's a CSV file. This says open up a window to let me select which one it is, and then call that object D1. So if I go like that, then again, the window pops up. I select attribution 2, and it's called D1. I could call it D2 if I wanted to. Same way, right? Same code. And now it's read in as D2. I can remove D1, and then it's gone. I could call this, some people do this like they'll call it my data equals that. I just choose to do D1 and D2 because it makes it easier when you're typing in code later on. I'm going to change my code back to where it says D1. So now I got this data set called D1. That's how I read it in. You can also go the slowpoke way, right? Read in from base R. In mine, it's even worse because I got to tell it like users, admin, downloads. Then I can select it. Right, and then here I pick what name I want, D2 or D1 or whatever. It doesn't matter how you do it. I'll just put that back to D1. Do it whichever way is best for you. You can do it both ways. I just choose to use the simpler way. You see how my R code here, let me see if I can pull this little thing where it lets me draw. Sometimes this thing will let me. All right, well, whatever. See how this is red? That means that my code hasn't been saved. It means I made changes to the code and I need to save it. So if I just go over here and click save, it'll save my code. I'll show you how to do this stuff later on in the class. Okay. Now, the next question you might have is, how do I access variables in the data set? So this data set, D1, has these variables: political knowledge, age coded that way, ideology, political interest, frequency of watching news, all these sorts of things, right? And let's say I'm interested in this variable like increase.min.wage. If I just type in increase.min.wage, I'm going to get an error message because it'll say I haven't found that object, because you have to tell R that this is a variable in this data set. So there's a couple of ways you can do it. The first thing you could do is just attach the data set. So if I typed in this command, and it's here in the slides, attach D1, then that tells R I'm only going to work with D1 data set. And so now when I type in increase.min, see, now it knows what I'm doing, and then it will show me that variable. So that's one way. You can attach it. The other thing, let's forget about that increase.min.wage. Let's say we're worried about political knowledge. So political knowledge is a variable I created. I asked people 5 questions in a survey, stuff like which party controls the House of Representatives, who's the Vice President of the United States, and then this is the percent that they got correct of those 5. So they could have 0%, 20%, 40%, 60%, 80%, 100%, and this just kind of shows you that. So the first thing I could do, if I typed in D1 $Polno, first I'm going to detach my data set, right? So detach D1. So now you'll see, if I just type in Polno again, I get an error message. So one way to access that object is to just tell it which data set I'm working with. And then I get that answer, right? Another thing you can use is this matrix notation, where you just go D1 bracket and then which rows you want and which columns you want. And since we want all of the rows, if I just type in D1 bracket and then leave that blank and just do comma 1, it'll give me the exact same thing. If I wanted rows 50 to 55, I could put those in there. Or if I wanted rows 150 to 1055, then give me just those ones by typing those rows in. So that's another way you can access it, just depending on what you want to do. Or you could just attach the variable. Again, I detach it, so if I just go attach D1, And now I can type in Paul No, and it'll work. I really don't have a preference of how you do things, right? You can do whatever works for you. I'm just showing you all the different things you can try to do. So in R, a lot of times when you have problems, it's because you're either trying to do something that doesn't make sense, like maybe you're trying to take the mean of a variable that's not a number, like male, female, you can't take the mean of that. So you couldn't make a histogram of that, for instance, right? So it could be that you're trying to do something that doesn't make sense, or it's because you've just got some little error, like you haven't capitalized something or you put something in lowercase or something like that, right? Like if I typed in right here, Paul No, well, I even misspelled it, right? But right, I'm going to get an error there. If I make these two lowercase, I'm going to get an error there. It has to be typed exactly right, or else R doesn't know what you're trying to do. The easiest way to find out like what your data are like is to use this summary function. So if I type in summary of Paul No, and it tells me the minimum value, the maximum value, the median, the mean, and then the interquartile range. And you could actually do that of your entire data set by just doing summary of D1. And then it'll show you for all of your variables in your data set. So I can find this one's a number, right? These ones are numbers, but this one's a categorical variable. So I could look for the mode with that, right? A categorical variable, so I could look for the mode. Education, categorical, look for the mode. But this one is a number. RV is a number. So then I can see the mean and the median on those. So that's the easiest way to find descriptive statistics in R. Just do the summary of the data set. The mean is one measure of central tendency. So with central tendency, you're trying to figure out the average of all the scores. The average is literally another word for the mean. So let me think of a better way to define it. Central tendencies, you're trying to describe the midpoint or the middle or the place in the data around which all things sort of converge. So there's three ways that you could do that in R. You can do the mean, the median, and the mode. Sorry, not in R, you can do them in anything. These are the three ways of trying to describe the middle of a data set. So the mean is the average, the median is the middle score, and then the mode is the most common. I'll show you each of them. So the mean, this probably looks a little frightening to you, but this means sum of, this is capital sigma. So this symbol means the mean of X, or the mean of a column of data, equals each observation, each row of that column, added up, and then divided by the number of rows, or the sample size. So as an example, if I wanted to know the mean for the number of customers in this store, I would go this plus this divided by 3 gives me that as the mean. Hopefully this is not a new concept to any of you. In R, I showed you one way you could do it. You can just type in mean Paul No, and that'll tell you the mean. You could also do the summary. So you could think about why the mean might be an imprecise measure of central tendency. What could change the mean so that it's not accurate or inflated or not perfectly descriptive, right? And it would be extreme values. If we go back to this example, this score is lower than the mean, this score is lower than the mean, this one is twice as high as this one and almost twice as high as this one. So because this value is so large, you get a mean value that exceeds that of 2 out of the 3 data points, right? So a large number or an unusually small number is going to change the value of the mean. So people use the median instead. The median is the point at which 50% of the data are above it and then 50% are below it. And I'll just demonstrate this for you with the Excel data, with the same data set in Excel, just because it makes it easier to see. So if I wanted to calculate the median like this, I would just take the whole data set, and then I would sort it on the value of political knowledge, and I would go smallest to largest. And we have 1052, I remember, from R. Let me just double check. 1052, right? So 1052 divided by 2 is 526. So I just, now that they're in order from smallest to largest, I just go down to row 526, and whatever value I find there, that's my median. So 526 is right here. 0.8 is my score, so my median value is 0.8. I could do that for any variable in this data set, right? It's not going to be the same thing. So if I wanted to find the, I don't know if you're familiar with the moral foundations, but if I wanted to know the median value for this height fairness moral foundation, I could just sort everything on that height fairness thing. There's two of them. It doesn't matter because then I go down to row 526 again. And then whichever value is on that row is my median. So I can't remember. One of those, which one is height? X. Okay. 294. That's my median score for that. That's how you do it. If there's two middle scores like there were on political knowledge, you could just split the difference or just pick one of them. In R, again, I would just type in summary of Paul No, and it tells me my median is 0.8. Okay. Here's some code you could use, but categorical variables are different than numeric variables. If you go back to this equation and you say add up all of the values, you cannot add up words, so you cannot calculate the mean. If you go to the median thing and say we're just going to put them all in order from smallest to biggest, you cannot do that because they're words. There is no smallest to biggest in a categorical variable. Let's look at this data set here, right? If I go political interest, not at all, or education, right? You could put them in order if you wanted to, but watch. Try and sort the data set education in Excel, education. All they'll let you do is sort it alphabetically. That's all you can do with the categorical variable. What does that mean? It's in some kind of order that you could find the median. So then if I go down to 526, whatever one's there in alphabetical order is going to be the median. That's silliness. That's ludicrous. That doesn't make sense. So what our median education is going to be a graduate degree because that's halfway in the alphabetical thing? No. All you can do with the categorical variable is you make a table and you see which one has the most respondents in that category. So if I were doing party identification, I've got 90 Democrats, 70 Republicans, and 140 independents. This one's the mode. So if I go back to my data set here and I look at these, I could find the mode for gender. It is male because there are more men than women. My mode for race is white because they're the most white people of race. And that's how you do it. So another simple way you could do it is in R, you could just make a table. Let's say it's party identification. If you just make a table of party identification, then you can see 237 Republicans, 318 Democrats, independent is the mode. More people say independent than any other political party. These people are missing values. 59 people didn't answer the question. All right, so let's have some fun. So there's this variable called Obamacare.insurance, capital F. In my survey, I asked people the question, how much they agree with certain statements from 0 to 100. I'll show you in Excel again, right? It's these variables here. Those ones are a different project. These ones here. From here to the end. And I asked people from 0 to 100, how much do you agree with these statements? So this one is poor people, NF wages. It's my code to help me remember that this is poor people are not being treated fairly with their wages or something like that, right? So 100, this person was 100% in agreement with that, and this person put a 10, means they pretty much disagree with that. This one's 100. We could actually look at it like, right? So that one said 100. They completely agree with that, and guess what? They're a Democrat. Although they call themselves independent. Oh, no, they are independent. Okay, that person, this is a different experiment. Okay, so this person is an independent and really agrees with that. And then what is this one right here? This person is a lean Democrat and strongly agrees with that statement. But this person is a strong Republican and they really don't agree with that statement. Okay, so this one. This is Obamacare is making insurance companies treat people fairly. And we want to know what's the mean value of that variable. So right in the middle would be 50, right? Completely agreeing would be 100. Completely disagreeing would be 0. What's the mean you get? So sometimes people will get a... Sometimes when you type in, you'll get NA as your answer. See? I just did. I got NA. That's because there are missing values. So a missing value gets read into R as NA. And then R says, wait a minute, I can't calculate that. Here, look, I can see right here. Obamacare Insurance F has 146 people that didn't answer it. So when I just say mean like that, it's going to give me NA as the answer. That's why it's one of the options here. And if that's what you thought the answer is, that's your mistake. Okay, so then I can find it either by looking at this and seeing what it is, or I can just type in that code, and if I say na.rm equals true, that tells R just ignore the missing values. And then I get that same answer, 51.96. Okay, what's the mean of Lilly Ledbetter approved? Go ahead and pause it, figure it out. In class, we'd have people vote and make sure you understand. So 60. And the median of that, of Lilly Ledbetter approved? Those are your options. Again, remember, if you just do a summary of the whole data set, you can look, and then here's lily.ledbetter.approve. Here's the mean. Sorry, here's the mean. Here's the median. So the median is 55. So then the question I want you to think about is, why is the median lower than the mean? Is it because of outliers? Is it because more people chose high values and chose low values? Is it because more people chose low values than high values, or is it because people didn't understand the question? So go ahead and pause and think about what you think the answer is. The way that I find out the answer to a question is I just do a histogram on these ones. So if I just do a histogram of Lily, then I can zoom in on this and see. So the median is lower than the mean because people chose extreme high values. Not as many people chose 0 as chose 100. Of course, most people are in the middle. Right? So when you have extreme high values, it's pulling your mean higher than what your median would be. So the answer to this is 2. More people chose extreme high values than chose extreme low values. And then the median of party ID, I already showed her. The median, you cannot calculate, is the answer to that. The mode, if you remember from when we made the table, is independent. Okay, so here's the thing that probably most of you didn't know how to do for homework 1, the Intro to RStudio assignment. So I'll show you how to do this now. Everything I've typed in gets saved here in this history. And I can create new code over here. Right there, that plus sign there. I say give me a new R script. It gives me a blank thing. And I can go over here and I can say, oh, I really like this code of how to read in a data set. and I liked this code of how to attach something, and I liked the row columns thing he showed me, and I did like this mean one, not that one because it doesn't have the NAs, but I do like that code, and I did like the histogram. And then if I go over here and I go send that over to the source, it sends it all over to this R code. And then I can just go save, and then choose any file name I want and give it a, I'll just call it central tendency dot R, and then it saves all of this as R code that I can use later on. So often what happens with R is people will do things in R and then they'll be afraid they're going to lose something. And so they'll leave their computer on, they'll leave R open and all that stuff. Don't do that. Follow these simple commands. Go to your history, save your code as a .r file, and then you can just open up that code again and do it all over again. I'll show you in case you don't believe me. So I'll just shut down R right now. And get rid of that stupid code because I don't need that code. And I don't need D1. Okay. So I'll close everything down. And I won't save anything because I don't need to. Now I'll just open up this code that I downloaded from iLearn. And then what I'll do is I'll select everything up here. Copy all that. And then I'll push Control Enter. And then the window will pop up asking me which data set I want to use, and I'll say Attribution 2. And now it'll run everything. Everything I did in class is all set. It all happened. Oh, except for psych. Let's see. No, that worked too. Yeah. Everything worked that I put in that R code. I could run it all again. I can take the mean of that variable. I can take the mean of that one. I can do the median. I can do the histogram. I can do it all again. So all you have to do in R is save your code. Don't worry about keeping things open. Don't worry about saving things when you're done. Just save the code. If you make a change, save the code, right? Like all these things all this code that I have open, all these things that I've done. If I type anything in it, I save the code, but then I close it and don't worry about it. I only keep all these tabs open because these are for various assignments and papers I work on, and I don't want to have to go open the files again. So I just keep them in my tabs. But you don't have to save it. Don't worry about saving anything. Except for like homework, sometimes I'll ask for pictures and stuff, but I'll show you how to do that some other time. Okay, so let's just go back to our modules, and we'll have a look at the homework. So your central tendency homework. Open this data set, calculate the mean, median, mode, min, max, range. Okay, I showed you how to do that. You can just go describe and it'll give you all of those things. And then it looks like there's a quiz of some kind that you're supposed to take. Yeah, well that's easy. Run those things and answer the quiz questions. That's awesome. So that homework should be easy. If I were you, I would do it right away while this stuff's fresh in your head. Otherwise, you might forget stuff. Okay, hope you all enjoyed. In class, make sure you ask questions on CampusWire if you have any.